Hello everybody. In this video, we shall see the various protocols which are associated with the IoT. Basically, IoT deals with the integration of the different physical devices with the interfaces, and these interfaces are communicating with each other with the help of various networks, which in turn called internetwork. So, whenever there is a communication over the different networks are concerned, protocols must and should function. So, IoTs can communicate over the networks with the help of the various set of protocols. So, we have different types of communication in general, we call them. It could be a copper wire based network communication. Currently, we use them for the local area network categories, various categories cables, cat cables. Earlier to that, we were using a different type of communication over a small network with the help of the coaxial cable. And currently, we are well versed with the fast communication with the help of optical fiber communication or wireless communication. So today, wherever we go, we get internet facility by means of OFC cables or by means of wireless communication. Maybe we are all well versed with the Geo's packages. So Geo is providing 5G network. So Geo is working with the totally wireless communication. So some of the times what we get to our home, an internet connectivity by means of the optical fiber cable. So this optical fiber cable also provides fast internet communication. So basically, these are all the various methods of getting communication for the IoT devices. Also, see, one point to note here is that we don't want a separate standard, separate connections, separate network, separate internet for IoT. Basically, IoTs are sharing our common network principles, our common network protocols. So, here, as we mentioned in our TCP/IP layering, basically we discussed two different types of models. One is ISO OSI model, open source interconnect model, which has got 7 different layers, and then the most popular model being TCP/IP model, which has 5 layers of communication, starting from the application layer down to the hardware layer. So we have different types of communication related to layers related to TCP/IP based communication. So the scope of this layer, link layer, is a local network connection to which the host is attached. Basically, our idea, the concept of IoT communication is attach these devices to the link layer of the local network connection. So whatever network we are using, the same network connection we need to connect the interface which in turn connects the IoT devices. So link layer determines how the packets are coded and signaled by the hardware devices or the medium to which the host is attached. So here the link layer, the responsibility of the link layer is to determine how the packets are generated from your IoT devices. How can we send those coded packets over the normal network? So how are we going to decode it at the destination end? So the concept is how do we manage the IoT devices in sending the signals or receiving the signals, converting those signals into data, then further making the data to communicate over the normal network lines. So here there are different types of linked layer protocol dedicated for the IoT communication. Application layer protocols normally do not connect to these IoT devices. Basically, application layer of the protocol, like HTTP or your different HTTPS or any other protocols which are connected to the mobile devices for managing or controlling the IoT devices. Basically, they are used at the application end, and IoT devices are not directly connected to the application protocol, so they need to send the signals. And IoT devices are connected to the link layer protocols. So here, one of the protocols in the link layer is 802.3 protocol. It's an Ethernet standard protocol which is defining a wired communication standard for local area network. So 802.3 linked layer protocol is an old protocol for Ethernet connection. We had different types of connections, topologies if we know topologies. So Ethernet is one of the topology where Ethernet protocol defines the wired communication standard for the local area networks. Here we use wired communication, and here the protocol's responsibility is to format the data, transmit the data, manage the data over the physical media such as twisted pair cable or even latest fiber cables. So this particular protocol is meant for wired communication for local area network, which manages twisted pair as well as fiber optics. So in the Internet of Things environment, the Ethernet is widely used to connect IoT gateways. Ethernet is widely used to connect the sensors, and Ethernet is used to widely connect the devices. So, which require high speed, reliable, and low latency communication. So basically, wired communication, which makes use of 802.3 linked layer protocol, is mainly used for gateways, IoT gateways, sensors, and devices that require high speed, reliable, and low latency communication. So this is one protocol which is very much important for IoT devices. So let's look into the key features of this particular protocol, 802.3 protocol. It is one of the features is it is wired communication. It is high speed. It supports the data at a rate of 10 Mbps. Of course, nowadays it is an old low speed, 100 Mbps, 1 Gbps, and 10 Gbps and higher. So we can expect a speed of 10 Gbps and around 10 Gbps for the 802.3 protocol. And it offers a full duplex communication. Full duplex communication means it is allowing transmission and reception of data simultaneously, which improves the throughput. Basically, most of the protocols, most of the standards in communication is full duplex communication, wherein at a time you can send the data as well as at a time you can receive the data. So media access controls, it uses CSMA-CD. It's an old concept of a link layer protocol. Carrier sense multiple access bar collision detection. So this is normally a standard which is used in the Ethernet based communication for avoiding the collisions and managing the data transmission. So here it uses CSMA bar CD for communication, and it is powered over Ethernet, PoE. So what is the meaning of PoE? It's one very important logic. So here the data is converted into electrical signals, electrical power to IoT devices through the same Ethernet cable. So it, as I already mentioned, CSMA bar CD, it's a wired communication which uses copper fiber cables, copper cable or fiber cable. Whenever it uses copper cable, it makes use of the data in terms of electrical signals. Whenever it uses fiber cable, it makes use of the data in the form of laser beam. So these are the two types of data what we expect here. But the concept of power over Ethernet (PoE) says that the cable is capable of sending data as well as electrical power to IoT devices. It's very much true that the device, IoT device, as well as the interface requires power. So in this case, power over Ethernet means you don't need a separate line. You don't need a separate power line for the device. So power line also is gone from the cable itself. So the cable contains two signals. One is a power as well as another is a data. So that is the meaning of power over Ethernet. Next is scalability. So it can be easily expandable by connecting more nodes using switches and routers. So we can expand. So normally, if you think that the cable, of course, the cable, the copper cable has got a maximum length beyond which the signal will be decayed, signal will be lost. You will not be able to regenerate the signal. But there is a logic. It is not the concept related to IoT, it is a concept related to communication, network communication, wherein you use repeaters in between, you use switches in between, you use routers in between so that the distance can be extended. Suppose if you think that a copper cable is capable of covering a distance of 300 meters, at the 300th meter you use one more switch so that it could extend to another 300 meters. Like this, scalability can be increased here in this example. So these are all the standards of 802.3 for communication. It's a linked layer protocol which is helpful for IoT devices. 802.3 is a protocol which is, it's a linked layer protocol for either copper wire based communication or optical fiber communication. It's a wired communication protocol. But most of the requirements say that instead of having wired communication, wireless communication is more preferable because controlling those devices or some application programs related to those devices require wireless communication. Because, for example, if I want to say that I want a door locking system which I want to make it automated, I want to treat it as an IoT. Somebody has come to my door home and my home is locked and I want to open that door and I am not available there. So if I want to, by looking at the CCTV camera, I know that they are my relatives or they are my homemates. So they don't have a key with them. So I would like to open the door. So what I do is I use my mobile application. So I will automatically send a signal to open the door. So the lock will be automatically opened. See the example, whatever I have given, strongly recommends a wireless communication standard. So here IoT requires a protocol which strongly supports wireless protocol. So under that condition we use 802.11 Wi-Fi protocol. It's a protocol which is commonly known as Wi-Fi wireless communication standard that enables a device to connect to a local area network and access the internet without physical cables. Basically, communication is as usual as described in the previous case also, but in this case there is no physical cable used. Everything works with the wireless, wherein wireless or Wi-Fi plays a very important role in connecting smart devices, in connecting sensors and controllers. Probably you might be knowing that wireless, solar power based wireless surveillance camera is available nowadays in the market, which is costing around 3,000 to 4,000 rupees, which doesn't require any power connection also. It has a storage backup also, and daytime it is charged by using the solar energy, and the signal is sent to the ground station via wireless signals or Wi-Fi signals. So like this we have a number of examples which use 802.11 protocol as a wireless protocol for wireless communication. So let us look into the key features of 802.11 protocol. It's a wireless protocol which works at a speed of 2.4 gigahertz to 5 gigahertz bandwidth. It is short to medium range communication. This particular protocol is used for a short range communication or a medium range communication. Basically, if I want to give example for this, I have a small garden in my home wherein I have put a CCTV camera, but I don't want to connect a wire to that. It is powered by using a solar lamp, and it is connected to the DVR which is located inside my house, and it is communicating via wireless with the short-term wave with the short-term range. It's a short-term range working at a speed of 2.4 gigahertz to 5 gigahertz. So it has a high data rate. It works at 11 Mbps up to several Gbps also. It works at a very high speed also because its range is very short. So there is no traffic involved in it. So that it can work at a very high data rate. So it covers a distance of 30 meters to 100 meters depending upon the router strength. As I already mentioned, we can think of connecting such devices in and around our garden or in and around our agricultural land, which covers a distance of 30 to 100 meters. So it is authenticated because, see, whenever there is a wireless communication, there is always a chance that some intruder may hack the wireless signals also. So under which condition you require an authentication. So here the data is already encrypted using WPA2 standard or WPA3 standard. So that unless or otherwise that decoding technique is available in the ground station, nobody can decode it. Signals come from the IoT devices through wireless in the form of encryption, so that decryption can be done at the ground station. So it's highly secured. So it uses IP-based communication. So there is IP address which is given to that, and it uses TCP/IP protocols for communication. Then infrastructure and ad hoc modes. So device can connect through access points directly in peer-to-peer P2P mode. So two ways are there. Direct connection is also there through access point. At the same time, peer-to-peer connection mode is also available. So these are the various key features of 802.11 protocol, which is used for IoT devices. Basically, it's a wireless protocol. Now we have one more protocol called 802.6.16. It's a WiMAX protocol. WiMAX protocol is worldwide interoperability for microwave access. Worldwide interoperability for microwave access, and it's defined with the standard 802.16. It's a wireless broadband communication protocol working at high speed, covering a long range connectivity and similar to cellular networks. Normally it is used by data center communications. So normally we use that in data centers. Normally data centers are highly secured centers which are placed in a very high secured place. Normally access to the data centers may not be available for a human being, normal man. Temperature controls are there, dust control is there, this control, that control, many controls are there wherein signals to those data centers can be done using this type of communication, data center communication. So here IoT, WiMAX plays an important role in connecting remote IoT devices where wired infrastructure is not available. So in these places wherein you have data centers, wherein all conditions are there, wherein you want to get the access of the data, you can use IoT with the 802.16 protocol, which is called WiMAX protocol. Let us look into the key features of WiMAX protocol. The frequency band of this is ranging between 2 to 11 gigahertz and 10 to 66 gigahertz. 2 to 11 gigahertz for non-line of sight. Non-line of sight is basically a long-range IoT communications. Line of sight is short distance wherein the device can be viewed by the people. Merely a feasible distance, I can say, a distance which could be seen few kilometers. But non-line of sight is a further distance communication, wherein this communication is done through wireless. So the data rate is at the 70 Mbps. That much speed is available. As I've already mentioned, the coverage ranges from 30 kilometers. So short distance can range from 8 to 16 kilometers, but it could go up to 50 kilometers. So it works with a point to multi-point communication. It works with the mesh topology for scalable IoT networks. Now, quality of service, it supports different quality of service classes for real-time, non-real-time, and best effort traffic. So it supports for all types of traffic, and it uses encryption and authentication. So in earlier case we use encryption, but here we use strong encryption as well as authentication to ensure secure IoT communication. So mobility, mobile WiMAX, we use 802.16e. Mobile WiMAX, which supports seamless handover for IoT devices in motion. So these are the key features of the 802.16 communication. So here we have seen the three different link layer protocols, which are 802.3 Ethernet protocol, which is a wired protocol, 802.11 Wi-Fi protocol, 802.16 WiMAX protocol. Both are wireless protocols. One is for a shorter distance and another one is for a longer distance. There's one more protocol is the 802.15.4 LRWPAN. That's one more protocol. So these are all protocols which are connected to the standard linked layer communication. At the same time, it's possible to connect these devices to the cellular protocols. So cellular work which work at a speed of 3G, 4G, or 5G. So there also there are certain linked layer protocols. So basically, this particular diagram shows the various four layers which are used, the protocol layers which are used for IoT based communication. The one which is working at application layer is your HTTP, COAP, FEP sockets, MQTT, as XMPP. XMPP is one protocol, DDS, AMQP. So these are all working at a higher layer. When it comes to transport layer, ultimately it is TCP as well as UDP which are working. And when it comes to network layer, ultimately IPv4 as well as IPv6 are working. In addition to that, we have 6LO wireless protocol which works. When it comes to linked layer, the lowermost layer, these are all the various protocols which are discussed will work here. So when it comes to 802.15.4 LRWPAN protocol, which works at a linked layer protocol, one more protocol. It's a protocol which defines low rate wireless personal area network protocol, LR, low rate wireless personal area network for personal area. It's a very small network based communication which uses the IoT based communication. So we use this communication for Zigbee, 6LO, WPAN, Thread, wireless HART. So these are all the various protocols which are making use of 802.15.4, but currently these are not very used for outside long range protocols, but definitely they are used for very small network which we call it a personal area network protocols. So the key features, data rate is at 20 kbps or 40 kbps or 100 kbps or 250 kbps. Frequency band is 868 megahertz to 915 megahertz. It could go even up to 2.4 gigahertz also. It's very low range, 110 to 100 meters range. Topology, it supports star topology, peer-to-peer and mesh topologies. Power consumption is very low. It uses CSMA by CA, collision avoidance protocol. It supports IPv4 16-bit short and 64-bit extended device address. Security, it uses AES 128-bit encryption for the data confidentiality and integrity. QoS, quality of service, it offers reliable data delivery with optional acknowledgement frames. So these are all the various small features of the 802.15.4 protocol. So already we know that linked layer protocol even uses 2G, 3G as well as 4G mobile communication. So we have mobile communication networks such as 2G, 3G, 4G. Today even 5G also has come. So all these protocols are well used by the link layer for the IoT communication. 2G, it's an old protocol used for GSM, Global System for Mobile Communication, and it uses GPRS, General Packet Radio Services, low rate data services. 3G, it uses a third generation. During 2000s, it is introduced. Bit higher rate universal mobile telecommunication system and high speed packet access is used. Now 4G LTE is used, and today we are at the stage of 5G protocols. So today we are at the fifth generation 5G. So 5G, fifth generation communication technology, is the most advanced technology. It uses a fast data communication, and probably today, because of the introduction of 5G, and most of the IoT communications and the applications related to IoT do not support earlier standards. They support only 5G, and today I'm able to look at my CCTV camera installed at my home remotely by using 5G technology. Suppose whenever it switches to 4G, it gives an error stating that low network bandwidth, so you're not able to watch. So whenever it comes to 5G, I'll be able to get the access of my CCTV camera, which is a IoT device. So basically today we are working at the fifth generation protocols. So basically we are working network layer protocols. Most of the time IPv6 is a standard protocol which is used for the network layer, but 6LoPA, low power wireless personal area network. So there is one more LOWPAN, one protocol is used, it's called 6 protocol IP. It's a version of IP for low power devices located at the not local area, personal area network at a distance of 10 meters protocol. So transport layer protocol, most of the time we use TCP as well as UDP protocols. So application layer protocols, we use HTTP, it's a common protocol. Constrained application protocol for machine to machine application, so COAP. Constrained application protocol for machine to machine. So auto communication. So when we go for auto communication, COAP is used, which uses request response model, runs on the top of the UDP, uses client server architecture. We also use WebSocket, MQTT, XMPP, DDS, AMQP. These are all the higher level protocols which we use in the protocols. So the functional blocks of the protocol, right? So these are the protocols which we use. Thank you.